Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and so far I have been showing you how to use JNI on Mac OS, which is also very similar to Linux platform, but now it's a good time to look at how we can set up our GCC compiler in Windows, and then set up our Eclipse in Windows and do mixed development using the Java native interface. So JNI for Windows platform. We know that GCC typically comes by default with Linux. So if you install any Linux distro, you probably get GCC automatically installed. On macOS, if you install Xcode, which is a macOS development platform and IDE, or you install command line tools, it just installs the GCC compiler. However, Windows doesn't come by default with GCC, or you cannot get it through Windows updates or anything like that. So what you need to do, you need to use a third-party package to install GCC on Windows. Now GCC only recognizes the Unix file system, which means in Unix we have user local include, user local lib, and these sort of folder structures, which we don't have on Windows, right? So when you install third-party GCC compilers, they create some sort of folder structure very similar to Unix in their installation folder, and you can use it to basically do for example, install external C++ libraries and then use them, include them in your C++ project. So on Windows, we typically have three options: Cygwin, MinGW, and MinGW Windows 64. And I mean, most operating systems right now are 64-bit, Windows or Mac OS or Linux. So there's a high chance that you need to install the 64-bit version of this third-party GCC compilers on Windows. You can also install Microsoft Visual C++, and that also has a compiler that Microsoft develops. So here I'm just going to use MinGW Windows 64-bit. So if you just install MinGW, that's the default. It's the 32-bit version. But if your Windows is 64-bit, your platform is 64-bit, you cannot use this 32-bit basically compiler. And that's because if you have a 64-bit Windows, you install a 64-bit Java JVM, and a 64-bit JVM cannot run 32-bit version of the dynamic libraries that you compile. Okay, it has to be 64-bit. So I'm going to basically in this tutorial, I'm going to focus on MinGW Windows 64-bit, right? So if you need to install it, you just Google it and then download and install. It's very easy. And then make sure you install the right one. So any of these third-party basically GCC compilers, Visual C++ or Cygwin or MinGW, make sure you install the right one in terms of 32-bit or 64-bit. And that's based on your JVM. So if you have a 64-bit JVM, you have to compile your dynamic libraries with a 64-bit compiler, all right? And when you set this up in Eclipse, when you create a new C++ project, it actually asks you what kind of tool chain you want to use, and you can choose Cygwin, MinGW, etc., right? So Eclipse already recognizes these third-party GCCs. But then you have to make sure that if you're using MinGW in the environment variable for your C++ project, you have to make sure that the home directory of your compiler is set to the root directory of where you install the compiler. So, and the root directory is where is the folder that includes the bin folder, the binary folder of the compiler. And I'll show you shortly what I mean by this. All right. So just make sure that when the Eclipse ID sets the home environment variable for your compiler, it points to the folder that includes the bin, right? And then dynamic libraries, we have talked this before. In Linux, the extension is .so, which is shared object. On macOS, it's .dylib. You can also use .so, but I guess .dylib is more specific to macOS. And then on Windows, we get .dll, all right? And again, if you compile with a 32-bit compiler, it creates a 32-bit version of the DLL. If you compile with a 64-bit compiler, it creates a 64-bit version of the DLL. And if your JVM is 64-bit, it cannot load a 32-bit DLL. You have to use a 64-bit DLL with a 64-bit JVM. So on Linux and Mac OS, you have to drop the lib from the beginning of the name. It automatically adds the lib from the beginning. On Windows, you must not, if you use Eclipse IDE and it adds the lib from the beginning, you must not drop the lib from the beginning of the name, right? It's only the convention of Mac OS and Linux, all these Unix-based operating system, that you have to drop the lib so that the JVM can load it. On Windows, you don't need to that. You have to use the full name of the dynamic library. You have to just drop the extension .dll, all right? On Windows, you do not. If the dynamic library has a lib extension, lib in front of its name, you do not drop it, all right? So on Windows, you only drop the .dll from the name so that the JVM can load it into the memory. All right, let's head to Windows. And this is my Windows 10. It's a 64-bit machine, and I have just installed Cygwin MinGW, which is the 32-bit, and then MinGW Windows 64-bit. So if you just search for MinGW Windows 64, you can go ahead and download it and install it. You go to the downloads page and you can download these. MinGW Windows builds, you can do this, download this one for example, and then if I go to my folder structures, so this PC, this is my drive, I have Cygwin 64-bit and MinGW, this is the 32-bit version, and MinGW Windows 64, alright. And again, if you look at the Cygwin, the root directory is where the bin is, so this folder is actually the bin directory. And then for MinGW 32-bit, the root directory again is where the bin is. So here, this folder is the root directory. And MinGW Windows 64, I have to go in, and this is where the root directory is. This is where the bin is, all right? And it has like the G++, GCC compilers, executable, okay? So this is and then the MinGW or Cygwin, they're not just the compiler, they also come with a package manager. So this is, for example, the MinGW installer that I have here. And if you look at the basic setup, you see all of these are 32-bit versions, all right? And then you can also search for the libraries and install any libraries. So these are more or less basically a package manager, all right? And then now in Eclipse, so we install these GCC compilers and packages, C++ on Windows, again Cygwin, MinGW, and MinGW-Windows 64. Now let's say I have installed a 64 JVM on this machine, all right, because I know my Windows was 64-bit, so I installed the right version of the JVM. So if I go to my Eclipse and switch to the C++ perspective and create a new C++ project, I'm going to select C++ managed build. And now here it asks me what toolchain I want to use, and it already detects that I have installed Cygwin and MinGW. So I'm going to select the Hello World C++ project template, and I'm going to use the MinGW GCC. Let's call this test 1. And next, okay, let's keep both debug and release. And it's going to build basically create the C++ project in the workspace. Let's remove these. And so this is the project. If you look at the include, right now it has user include and then GCC, and and all of these come from the Cygwin. But we selected MinGW, and the reason is that the home directory is not set properly, so it cannot figure out what's going on. So if I right click on my C++ project, go to property, and on the C++ build, and in the environment, if you look at here, you see that MinGW home is not set to the MinGW folder, it's set to Cygwin, right? So what I need to do, I need to go to the root directory of the MinGW, and the root directory is where the bin is. So this folder is the root directory, and then I'm going to copy this and edit this home environment variable, MinGW home, paste, OK, apply and close. Now it's going to change this includes to point directly, because each of these compilers, MinGW for example, they all have this include that has all the header files, all the default libraries that come with the C++ or C. Same for Cygwin, and again it has a home directory and a development, and it eventually has all the includes. All right, same for MinGW 64-bit, it has the include that has all the 64-bit header files. All right, so now if we look at the include, now all the includes are correctly pointed to MinGW and there is no problem here. Okay, and so we have this MinGW include. These are all the header files, and then include MinGW lib gcc MinGW Windows 32, and so these are all the 32-bit version of the header files. All right, so if I compile this, right, or basically if I build it in the debug mode, it runs the G++, okay, and build finishes, there is no error. It was able to create this executable. If I run this test one, yeah, it works, right? Hello world. So it seems to work fine. It was able to compile, but then the problem here is that, as you can see, this object, this executable is annotated with x86, which means this is only a 32-bit version. All right, not a 64-bit version. And on a 64-bit machine we can run both 32-bit and 64-bit executable. That's why I can run this in a 32-bit mode and it still works fine, right? But if I create a JNI project and use the 32-bit, it's not going to work. It's going to, the JVM is going to complain and says that I cannot load it because it's a 32-bit basically dynamic library. So let's quickly try to do this. So I'm going to Java perspective, and then let's create a new Java project, Java, or maybe basically let's call this native, and I'm selecting the Java 1.8 JDK 8 and finish. So this is our native, and then what I'm going to do is just create a new object here, class. Let's call this person, and okay, maybe let's delete it, and let's also delete this package, or maybe let's create a new package. Package, let's call this native example, and then let's create a new package class inside this person, and then person has a string name and int age, and then I'm going to create a person, the constructor, public person, a string name and int age, and then this dot name is name and this dot age is age, and then I'm going to give it a maybe just override to a string method, or maybe just let's give it a method, public print info, and then sysout name is plus name, and then age is okay, we can add a space here, plus age. All right, and the return type is void here. All right, this is our person, and let's create a test class test person, and I want to have a main method, and here let's say test1, and then let's say public static void test1, and then person Bob is create person Bob and then 21, and this create person is going to be a static native. So public static native, the return type is person, create person, a string name, and int age. So I'm going to create, and then we're going to say bob.printinfo. All right, so we set up a very simple example, and now what I need to do, I need to create a C++ project. So let's go to the C perspective and new C++ project, C++ managed build, and let's set it with MinGW. Let's call it native_C, and then let's have both debug and release. That's fine. And native C. So again, we need to change the MinGW home. So C colon / MinGW. Okay, so the include is now working, and then I should be able to build this project and be able to run it. Yes, all right. And again, this MinGW right now it's a 34-bit, so Win 32-bit, and you see that the executable is 32-bit. So what we need to do, let's clean it up first, because I don't want to create a basically executable. I want to go to the settings, and then in the settings I am going to go to build artifacts, change it to shared library. So it adds the lib to the beginning, but we don't actually need this. This is a default that Eclipse adds, but the extension must be DLL. So let's keep the lib from the beginning. You can remove it, so you don't really need to have a prefix here, but let's keep it. So if I build this, now it creates a DLL for me, and as you can see, the DLL is x86 or only 32-bit. So this is only a 32-bit DLL. All right. And let's create a header folder, or basically a source folder, call it header. All right. And then so what we need to do, we need to select our test person that has a native method, and then let's run our Java H tool. And I want, so the working directory is the bin, because Java H acts on a binary, and -d workspace. Let's call the so I want create the header file and put it inside the native C project. All right, and then let's run this, and let's run the Java H again. Not okay, so why do we get an error here? Let's go back to the Java H configuration, workspace, native_C, and then header, and then -JNI. Okay, so the working directory is workspace native. This is our Java project bin, the bin directory of our Java project, and then this is the header folder of our C++ project. So this should work. Yes, we should get the header file, or yes, we're getting the header file. And then I'm going to go back to here. Let's delete this, and then let's create a new source file, CPP file. So source file, let's call it native underscore example.cpp. And then we need to now include the JDK. So properties, and then on the settings, tool settings, G++ compiler, and then we have this include. So include paths, these are the folders. See, I have already installed so JDK, we go to the include folder. This has the JNI, and then we also include the Win32. Okay, so apply, yes, and now these errors should go away. So if I hit Control and click on JNI, it should be able to find it. Yes, And then we copy and paste this header file into our CPP. But before that, we have to include our header file, dot header, and then native example, and then copy and paste the prototypes. JNI environment pointer is JVM. J class is the calling class because this is a static method. So underscore class. J string is let's call this name, and J int, let's call it age. All right. And now the implementation is simple. We need to get a J class of the person. So person underscore class is JVM find class, and then we have to specify the class path, which is in the native underscore example package, and then person, and then we want to invoke the constructor. So J method ID, constructor ID is JVM find or get method ID, and the J class is person class. The name of the constructor is init, and the signature is basically a string and an int. So L semicolon, a Java object which is a string and then integer, and this is the basically the parameter type, and the return type of the constructor is always void, and the object here is java /lang/ string. All right. And then I'm going to say basically J object person obj is JVM new object, and then person class method ID constructor, and then we have this vararg parameter for the parameter list. We have to specify a J string which is name and J int which is age, and then we're going to return this object, return person underscore obj. All right, this is all we have to do. Let's build this. Build is successful. We have lib native underscore c.dll, and this is a 32-bit, and then let's create a folder in our Java project. Let's call this JNI. All right, and then let's go back to our Java and then copy and paste this dynamic library to our Java project. And then what we're going to do, we're going to go to the build path of our Java project, configure build path, and then in the native source, I'm going to say native library location. I'm going to edit it and workspace and then JNI. All right. And then because we are using this native in this class, we're going to use a static initializer to load the dynamic library. And as we said in Windows, we don't, if there is a lib at the beginning of the name, we don't drop this lib, right? It's only for macOS and Linux that the JVM needs to, for us to drop the lib. So lib native, we only drop the extension. Only drop the extension .dll, all right? Whatever the name is, you write the full name. In Windows and Mac, we have to drop the lib from the beginning. All right, so let's see if this works. A Java exception occurred, and no lib native in java.library.path. Oh, that's because there is also underscore C here. This is the name. So let's run this again. A Java exception occurred, and now it complains and can't load IA32-bit DLL on an AMD 64-bit platform. Basically, this means is that you are loading a 32-bit DLL, but the JVM is 64-bit and it doesn't allow to load a 32-bit. However, we saw that if we have a 32-bit executable, we can actually execute it on a 64-bit machine. But the JVM doesn't do that. The JVM doesn't allow you to run or load a 32-bit DLL in a 64-bit JVM. It doesn't allow. And this is opposite to, again, the fact that if you have a 32-bit executable, we can actually execute it on a 64-bit machine. But it's not the case for the JVM for loading the 32-bit DLLs when it's 64-bit, all right? So what's the solution here? We have to configure our C++ project so that it uses the 64-bit version of MinGW. And again, the MinGW is 32-bit. MinGW hyphen Windows 64 is a 64-bit. So if your Windows is 64-bit, you have to run or basically install the 64-bit. And the root here is where the bin is. So this is the root of my 64-bit MinGW. So in Eclipse IDE, I go to the C++ build environment and change the home environment variable for the root of this compiler, MinGW. Edit. So paste. And now if I apply, you see that now the includes change. If I look at the includes, now the includes are pointing to the MinGW 64. Which means if I now build it, it builds with the 64-bit compiler instead of the 32-bit compiler. So if I build this again, notice what happens. I guess what we need, because we need to clean it up. So let's delete the debug folder or the previous file, and now let's build it again. Now it builds, and notice what it says about the DLL. It says AMD 64. This means this is a 64-bit DLL. This is not x86. This is not 32-bit. And now let's delete our previous dynamic library in the Java project, and let's copy and paste this. All right. Now this DLL is 64-bit, so hopefully the JVM is not going to complain anymore. So let's run our Java code. And as you can see, now a JVM allows us to actually load this dynamic library because it's a 64-bit, and my JVM is also 64-bit. And if we load that, we create our person object in C++ and then send it to Java, and in Java we invoke the print info method. So I hope you understand this process. This is very important, that if your JVM is 64-bit, you have to use a DLL that is 64-bit. It doesn't allow you to load 32-bit DLLs. But in terms of the executable, C++ executable, you can actually run a 32-bit executable on a 64-bit machine or on a 64-bit operating system. However, JVM doesn't allow you to do this. So if you want to figure out whether or not your JVM is 64-bit, you can use one of the methods in the system class. So let's create test2 here quickly. Test2. And in system class we have so system.getProperties. All right. And this get properties, it returns a properties object. So properties p equals this. And I guess we need to import this from the Java util. And these properties, I believe it's a hash map, so we can quickly have a look at these properties. And it's trying to open it. Still trying to disassemble. Okay, never mind. So let's do, I guess, we can do maybe a sysout on P. Let's run this. And it has all the basically properties in a nice, and it's a hash map, right? So I can say a set of whatever. Let's import the set. Keys is p dot key set. All right, and then for k, for basically key set, this returns a set of objects, right? So for object k in keys, we want to say that sysout k plus p dot get k. And let's also import the set. So hopefully we should be able to do a iteration. And let's look at my system properties that the Java knows. So there is an architecture, there should be an architecture here, os.architecture, and it says AMD 64-bit. All right, so the JVM checks this and says, okay, your system is 64-bit, so I don't allow you to load a 32-bit DLL, a 32-bit dynamic library into into JVM. It has to be 64-bit. I hope you understand this, and I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.